Hello everyone, I am Pratik Jain, Assistant Professor in the Department of Computer Science and Engineering, IPS Academy, Institute of Engineering Science. Here I am today to present a lecture on concept of object and classes in object-oriented programming. These are the content of my topic. First, introduction of object-oriented programming, concept of object-oriented programming and methodology, object, class, and examples of object and class. Introduction. Object-oriented programming is a computer programming model that organizes software design around data or objects rather than functions and logic. An object can be defined as a field that has unique attributes and behavior. Object-oriented focuses on the objects that developer wants to manipulate rather than the logic required to manipulate them. This approach to programming is well suited for programs that are large, complex, and actively updated or maintained. Additional benefits of object-oriented programming include reusability, scalability, and efficiency. The first step in object-oriented is to collect all the objects a programmer wants to manipulate and identify how they relate to each other, an exercise often known as data modeling. Examples of an object can range from physical entities such as human being, who is described by property like name and address, down to small computer programs such as widgets. Once an object is known, it is labeled with a class of objects that defines the kind of data it contains and any logic sequences that can manipulate it. Each distinct logic sequence is known as a method. Objects can communicate with well-defined interface called messages. Concept of object-oriented programming. Basically, there are 7 concepts that are based on object-oriented programming. They are as follows. First, object. Second, class. Third, data encapsulation. Fourth, data abstraction. Fifth, inheritance. Sixth, polymorphism. And seventh one is message passing. What is object? In computer science, an object can be a variable, a data structure, a function, or a method, and as such is a value in memory referenced by an identifier. The class-based and object-oriented programming paradigm, the object refers to a particular instance of a class, where the object can be a combination of variables, functions, and data structures. The following object description are examples of some of the most common design patterns for objects. Function objects, an object with a single method. In C++, this method would be the function operator that acts much like a function, like C++ pointer to a function. Operator overloading is an example of which we cover in polymorphism. Immutable object, an object set up with a fixed state at creation time and which does not change afterward. First class object, an object that can be used without restriction. Container object, an object that can contain other objects. Factory object, an object whose purpose is to create other objects. Meta object, an object from which other object can be created. Compare with a class, which is not necessarily an object. Prototype object, a specialized meta object from which other object can be created by copying. God object, an object that knows or does too much. Singleton object, an object that is the only instance of its class during the lifetime of the program. Filter object, an object that receives a stream of data as its input and transform it into objects output. Often the input and output streams are streams of character, but this also may be streams of arbitrary objects. These are generally used in wrappers since conceal the existing implementation with the abstraction required at the developer site. In class. In object-oriented programming, a class is an extensible program code template for creating objects, providing initial values for state and implementation of behavior. In many languages, the class name is used as a name for the class, the name for the default constructor of the class, and as a type of other object generated by instantiating the class. These distinct concepts are easily conflated. Now, we understand the concept of object and class. Now, we understand the concept of data encapsulation. What is data encapsulation? Data encapsulation is nothing but wrapping up of data in one class. So creating a class is an example of data encapsulation. Why we need data encapsulation? The basic concept, basic question arises in all of us is why we need data encapsulation. We are having structured programming earlier, but object-oriented programming comes and it gives us data encapsulation. By encapsulating the data, we can wrap the data and we can secure our data from the outside world. We can provide access specifier to all the member functions and data members so that it can be made public, private, and protected. So data encapsulation is very much important to hide the data. And what is data abstraction? Data abstraction is showing up only the essential things and hiding the background detail of all. Means if you are surfing any of the website, for example, ies.ipsacademy.org, then only thing we will see is that the web page containing the tabs, home page and the department, and all the coding part is hidden. So this is the feature given by object-oriented programming, that only essential feature will be seen to the user and hiding the all background details. Inheritance. Now, inheritance is very important concept in object-oriented programming. So, inheritance. The basic definition of inheritance is reusability. Simply means that we have to reuse all the codes. Okay. So, there are 5 types of inheritance. Number 1, single inheritance. Number 2, multiple inheritance. Number 3, multi-level inheritance. Number 4, hierarchical inheritance. And number 5, hybrid inheritance. So, what is single inheritance? Let us consider by a block diagram of it. Single inheritance. Single inheritance is nothing in which we are using single base class and single drive class. If class A and class B, there are 2 classes in which class B is using the function of class A, then it is known as single inheritance. Means there are only single inherit class. Second one is multiple inheritance. This is the example of multiple inheritance, in which we have more than one base class. And more than one base class is deriving a single derived class. So derived class can have more than one base class. Then it is example of multiple inheritance. The third one is multi-level inheritance. multi-level inheritance. In multi-level inheritance, we have level of base and derived class. Let us take the example of multi-level inheritance. In multi-level inheritance, A is the base class of B. Simultaneously, B is the base class of C. So, indirectly, C is the base class of A. So, can we say that A is directly a base class of C? No, we cannot say this. If it is a private inheritance, then we can say that the public member of A become the private member of B. So it cannot be accessed to C. So multi-level inheritance is given to secure the levels. The fourth example of inheritance is hierarchical inheritance. Hierarchical inheritance. In hierarchical inheritance, we have the hierarchy, which is going downward. Means we have A as a base class, which have two derived class, B and C separately, and C can have another derived class D. Also, B also can have another derived class as E, and so on. So, hierarchical inheritance is just opposite of multiple inheritance. In multiple inheritance, we have more than one base class. In hierarchical inheritance, we have more than one derived class. We can have more than one derived class. So, another example of inheritance is hybrid inheritance. So what is hybrid inheritance? We all know the meaning of hybrid, which is a mixture of one and more things. So the mixture of more than one or two inheritance is known as hybrid inheritance. The basic example we take is this: A, B, C, and D. This is the example of hybrid inheritance. We can say this, that A and B follow single inheritance, A, B, and C follow hierarchical inheritance, B, C, and D follow multiple inheritance, and A, B, C, and A, C, D follow multi-level inheritance. If we are following more than one inheritance, it can be considered as hybrid inheritance. The basic problem arises here is ambiguity error, because the member function and data members of A derive two times simultaneously to D, which causes ambiguity error, which can be resolved by using virtual function, the virtual base class. This is inheritance for you. Now, what is polymorphism? Polymorphism is nothing but it means that many form. Poly means many, morphism means form. Many form means single name, multiple functionality. It is basically of two types: compile time polymorphism second one is runtime polymorphism. Before understanding polymorphism, I will explain you with a small example. Let us take an example volume. Okay. A volume, if we declare function volume in a program and we define volume to find out the volume of cone, to find out the volume of cylinder, and to find out the volume of sphere. It means that a single name is performing three different tasks for creating, for defining volume of sphere, for defining the volume of cone, for defining the volume of cuboid or anything else. Single name, multiple work is known as polymorphism. Means Compile time polymorphism. Compile time polymorphism have two examples. First, function overloading. Second one is operator overloading. The example I have given for a volume is the example of function overloading. Operator overloading is nothing in which we can overload binary and unary operators. And the example of runtime polymorphism is virtual function and pure virtual function. Pure virtual function. Pure virtual function is used to create abstract class, which means it supports data abstraction. The last topic is message passing. Message passing is nothing, is when we create an object and call the function, then the concept of message passing occurs. So these are the theoretical representation of our. Now, let us take example